Hello everyone. Today we are excited to present our warehouse management system. So this web application is designed to manage inventory, custom records, supplier information, warehouse locations, employee data, and orders in an efficient and user-friendly way. We are choose this application for our course project because warehouse and logistic management are essential in many industries. Having a centralized system that allows you to monitor and manage data can increase efficiency, reduce human error, and streamline operations. Our project contains of three key layers. The front end built with the JavaScript framework React.js used for all user interaction. The backend built with the Django REST framework responsible for handling business logic and processing requests. A MySQL relational database management system to store and manage data efficiently. Let's take a tour of our interface. As you can see on the Human page, users are greeted with a header and two major sections: customer list and inventory list. Each section is interactive and connected directly to the backend application programming interface. Let's now go over our basic functions. Will customers. Users can view all customer data pulled from backend in real time. Will inventory. Will inventory. Inventory items are listed with category, name, and quantity. Upload Excel. Users can upload an Excel file with structured sheets like customers, orders, employees, and more. REST API browsing. Through Django's browsable API, users can explore the get and post functionalities for each endpoint. Basic function. Users can add new customer or employee data directly through Django's admin interface or the API post methods. The admin panel provides form-based insertion while the API supports JSON formatted post request. Now let's talk about advanced functions. The first is restock button. This is a post-based API call that increases item quantity if below a threshold. Excel parser with sheet mapping automatically process with 6 sheets and inserts to appropriate database table. And the next is inventory list and the restock feature. Each inventory item is listed with its name and the current quantity. We have added a customer restock button for each item. When clicked, it will trigger a post request to the backend. If the inventory quantity is below a specific restock threshold, the quantity will be increased automatically. And the Excel upload web page. On our dedicated Excel upload page, users can select a Microsoft Excel file and upload it to the backend. The interface is clean and minimalistic, showing only the file chooser and a submission button. This provides administrators with a quick and easy way to import structured data into the system.
Okay, next is let me introduce the rest. Excel upload the backend process. Once the Excel file is uploaded, our Django backend uses panel libraries to parse each worksheet, which includes customers, inventory, orders, employees, suppliers, and warehouses. It then iterates through each row and inserts the data into the corresponding MySQL tables. The backend performs validation and skips duplicate entries to maintain data integrity. Next part is Django REST framework at the main panel. We also integrated Django's built-in administration interface. It allows system staff to view, add, update, and delete entries in all six core database tables. Each model is registered under the API section in the admin portal, and all foreign key relationships are preserved during modifications. Unstructured query language table overview. In our database named Warehouse Management, we created the following structured tables. API customers. It includes customer ID, name, contact details, address. API employee. It includes employee ID, name, role, assigned area. Next one is API inventory. It includes item ID, name, category, quantity, location ID. Location ID is a foreign key here, and the supplier ID is also a foreign key. Next one is API orders. It includes order ID, customer ID. Customer ID is a foreign key here. Item ID is a foreign key here. Quantity, status, order date. Next one is API supplier. Supplier, it includes supplier ID, name, contact details, product list. And the last one is API warehouse location warehouse. It includes location ID, aisles, shelf, and capacity. These tables these tables are designed with proper indexing and foreign key constraints to ensure data consistency and efficient queries. Next part is entity relationship and rational models. We constructed a complete entity relationship diagram and then converted it into a rational schema. It includes one-to-many relationships, such as between warehouses and inventories, and customers and orders were accurately implemented using Django model relationships and enforced by foreign key fields. Next part is SQL table exploration. Our SQL database management system provides support for columns, foreign key constraints, indexes, and triggers. Each of our table includes columns that represent businesses, entities, and their attributes, along with indexes to speed up queries and enforce referential integrity between tables.
Now I'm going to introduce our tables. The first one is suppliers table, which includes a supplier name and contact details, product list. Second table is warehouse table. It includes location, asset, shelf capacity. Next one is employee table, which contains employee name, role, assigned area, location ID. And next one is customers. Customers includes name and contact details, address. We input every data in 15 peoples. And next one is inventory table. Inventory table contains name, items ID, category, quality, location, and supplier. And order table, we contain the order ID, customers, items, quality, status, order data, and employees. And for the key relationship, we included inventory is linked to suppliers and warehouse through foreign keys. Orders reference customers and inventory. Employees are assigned to area within the warehouse when ensuring the design adhere as to at least 3NF to eliminate data redundancy and maintain data integrity. All functional dependency are clearly resolved, and primary key and foreign key enforce referential integrity. Most tables are satisfied BCNF as well. Now let her introduce us. Continue.
For extra features and improvements, in addition to the basic features, we implemented the following enhancements: restock logic with a threshold-based API using post request, Excel file parser that supports importing data from multiple worksheets in one batch operation, Django admin panel for real-time database inspection and manipulation, real-time user interface updates with confirmation message after successful operations. For the technologies used for front end, we use React.js JavaScript framework. Backend is Django framework with Django REST framework for API development. Database is MySQL relational database management system. Excel parsing, we use Python Panda library, API communication, Exos JavaScript library for making HTTP requests. From this project, we learned how to integrate front end and back end layers, handle foreign key constraints, design RESTful API as debugs common Django related errors and process structured as Excel data. We also focused on improving user experience through clean user interface feedback and the form validations. For future improvement, we want to enhance this system further. We plan to implement the following: full create, read, update, delete operation for all data tables from the front end, authentication and user rule-based access control, exporting reports in portable document format, adding dashboard style data visualization and charts, real-time notification for inventory levels falling below restock thresholds, history logs for order and inventory changes, scheduled batch imports from online storage like Dropbox or Google Drive, automated emails for order confirmations or restock alerts. At the end, I thank you for watching our demonstration. We hope you enjoyed the walkthrough of our household management system and understand how each part of the applications contributes to practical and complete solutions for managing warehouse operations. We welcome any questions and look forward to your feedback. Thank you.
Thank you.
Thank you.